Hello students, in this video we'll discuss the Codazzi-Mainardi equations. So the Codazzi-Mainardi equations. Okay, these are fairly easy to derive, right? And the idea is the following. So we get these by equating coefficients and second derivatives, right? So let's recall a couple things. Let's recall that RU is equal to what? Is equal to gamma 1, 1, 1 RU plus gamma 2, 1, 1 RV plus Ln hat, that RUV is equal to gamma 1, 2, 1 RU plus gamma 1, 2, 2 RV plus M n hat, and then finally gamma, then RVV for surface parameterization, right? So we can say let's let S be a surface with parameterization R of UV. Great, okay. And so this will finally be gamma 221 RU plus gamma 222 RV plus N, where L, M, and N are the coefficients of the second fundamental form. Great. Now what do we know? So one thing we know, for example, is I know that RUUV is equal to RUV U by the equality of mixed partial derivatives, right? So let's take that relationship over there and write it out in terms of these Christoffel symbols, right? So what would this tell me over here? These equality of mixed partials tells me what? So this equation over here is equivalent to what? This is equivalent to saying the v derivative of this expression over here. So in other words, I'm going to have a gamma 1, 1, 1 RU plus gamma 1, 1, 2 RV plus Ln. The v derivative of this thing has to be equal to what? Has to be equal to the u derivative. So I said the v derivative of this has to be the u derivative of this, right? So a gamma 1, 2, 1 RU plus gamma 1, 2, 2 RV plus M n hat, and then finally a what? And then I'm going to do a u derivative of this. Okay, beautiful. Now what I'm going to do is I'm going to take all the coefficients. I'm going to equate the coefficients of the normal vector over here, right? So let's do that slowly over here. So what we have, let's do this carefully. So I want to write down all the coefficients that have derivatives of RUV over on the other side of the equation, right? So what we do over here is we'll have a gamma of 1, 1, 1, gamma 1, 1, 1, the v derivative of this, that's going to be an RU component, and there's going to be an RU component over here. I'm going to subtract off gamma of 1, 2, 1. That's going to be a u derivative of that. And those, if I do a u derivative of this thing over here and then a v derivative of this thing over here, those are going to be the coefficient of RU. So that's going to be an RU term. What's going to be my, let's look at the RV term over here. So the RV term is going to be what? The RV term, I'm going to forget about the n derivatives for a second over here. So I'm going to have a what? I'm going to have a gamma of 1, 1, 2 v. That's going to be an RV term over here. And then what will the RV term be over here? The RV term over here is going to be a u derivative of this thing. So minus gamma 1, 2, 2. That's going to be a u derivative of that. Those are going to be my RV terms. Okay. And then what are the n terms going to be over here? So the n terms over here, I'm going to have a what? I'm going to write those things over here. That's going to be an LV minus MU N hat, okay? So in other words, I put all the terms that don't have any second derivatives over on this left-hand side of the equation, and this is going to be equal to what? So now this is going to be equal to, let's look at this carefully over here. So we're going to have some RUU terms, right? So we're going to have a gamma of 1, 2, 1, and that's going to be an RUU term over there. So it's going to be RUU, but what is RUU? RUU is going to be a gamma 1, 1, 1 RU plus gamma 1, 1, 2 RV plus a L times n hat, like that. Beautiful. That was my RUU. Now I'm going to have an RVU and an RVU over here. So what's that going to be? That's going to be a, what we have total over there. So there's going to be a, this will remain positive, that's going to be negative, so that's going to be a plus gamma 1, 2, 2 minus gamma 1, 1, 1. And those terms over there have a total factor of what? Those terms are going to be RUV terms. So it's going to be a gamma 1, 2, 1 RU plus gamma 1, 2, 2 RV plus an M and like so. Beautiful. Okay. Excellent. And so now what? And so now we are going to look at the next term over here. So then we're going to finally have a what? So we have an RVV term over here. So our RVV term plus the RVV term is going to be what? So the RVV term is going to be put on the other side of the equation. So that's going to be a minus. This turns into a minus gamma of 1, 1, 1, 1, 2. And then the RVVs are going to be gamma 2, 2, 1 RU plus gamma 2, 2, 2 RV plus N hat like so. Beautiful. Okay. And then the what terms do we have? Then we have the, I'm going to throw everything on the other side over here. Then we have a plus an M and U minus L and V. Okay, so we get, so now I put all the second derivative terms over here. And so now what do we have over here? So now I can relate the coefficients of n. So what are the coefficients of n over here? So that tells me the first thing over here is that LV, so I have an LV minus MU minus MU. So that's the coefficient of n over here. And what's the coefficient of n over here? It's going to be equal to an L, so it's going to be a gamma 1, 1, 2, and then times L. And then over here, we're going to have a plus M times gamma of 1, 2, 1, 1, 2, 2, minus gamma 1, 1, 1. And then finally, this negative n gamma 1, 1, 2 like that. And so this equation over here is the first Codazzi-Mainardi equation. Let's do the second one now. The second equation is going to be what? So now I'm going to equate the following relationships. I'm going to equate R, then I did a UUV, so I'm going to do a VVU has to be equal to RUV and then a V like this, okay? So let's write out that equation over there and see what we're going to get. So this thing over here, so RUV is going to be a what? That's going to be a, down over here, it's going to be a gamma 2, 2, 1 RU plus gamma 2, 2, 2 RV plus an N hat U is equal to what? It is equal to a gamma 1, 2, 1 RU plus gamma 1, 2, 2 RV plus a what? Plus an N hat, and that's in the direction of V. And so now again, what we're going to do is we're just going to succinctly figure out what the coefficients of n hat is going to be. Let's look at the coefficient of n hat, okay? So on one side of the equation, when we have an n sub u from this thing over here, that's going to be a coefficient of n hat. And then a what? And then over here we have a minus mv. That's going to be on the left-hand side. And that's one thing we're going to have. And then what we're going to need is we're going to need to do the same thing over here. We're going to have to put all the second derivatives on one side of the equation of the coefficients of n, right? So we're going to do that next. So what will that be? So there's going to be no derivatives over here, just the single terms over here. So let's do that next calculation. So we'll have a, that's one thing we're going to get. The second thing we're going to get is we're going to have a, let's calculate this out slowly over here. We're going to have a negative gamma 2, 2, 1, right? That's going to be this term over here. It's going to be two u derivatives over here. So it's going to be something with an RU, something with an RV, and then what? And then over here, the RUU term has an L and hat like that, okay? That's going to be this term over here, the second derivative. Then we also have this term over here with a negative and this term over here with a positive. So it's going to be a plus gamma what? Plus gamma 1, 2, 2 minus gamma 2, 2, 2. And then again, we're going to have something with an RU, something with an RV, and then a what? And then both those terms, the RUV and then the RVU terms have an M over here with an N hat. Beautiful. And then finally what? And then finally this RVV term over here is going to be a plus gamma 1, 2, 2, like so. And then that's going to have an expression that involves what? Something star RU, something star RV. And then finally a what? That's going to be a VV, so that term's going to have an N hat like this. Beautiful. And so now I can equate these things to find the second Codazzi-Mainardi equation, which says what? It says NU minus MV is equal to what? Is equal to gamma 1, 2, 2, N, like this. And then a plus gamma 1, 2, 2 minus gamma 2, 2, 2. That's going to be an M. And then finally a minus L times gamma 2, 2, 1. And that's the second Codazzi-Mainardi equation. And these two equations over here need to be satisfied on a surface in order for the surface to have a consistent sort of atlas or consistent chart over here. So these are oftentimes referred to as one of the two compatibility conditions for a surface chart parameterization. We'll see that the Gauss equations, which relate the coefficients of Ru and Rv to each other, give a formula for the Gaussian curvature in terms of the first fundamental form and derivatives of the first fundamental form, which is the basis of the theorema regium of Gauss, which says that the under isometries, the Gaussian curvature is an invariant, which we'll prove in a further video. Thank you very much.